So question 2. Which of the following is true for most metals? Okay, so I'm looking at properties of metals. So they are dull. No, that's not right. I know they're shiny. They've got low melting points. No, again, I know that it takes a lot of heat to melt a metal. They're found on the right-hand side of the periodic table. Nope, they're gases. And so the answer must be they are malleable. And if I didn't know, the word malleable means bendy. So that is correct. Part B, aluminium is a metal. Aluminium is used in overhead power lines. The power lines are supported by pylons as shown in figure 3. So there's my pylons and there are my power lines. So I know that these power lines are made of aluminium. So I'm just going to write that down just to remind myself. So it says, which diagram shows the arrangement of atoms in the aluminium metal? So at this point here, I know that this is going to be a solid. So I've got 3 diagrams. I've got a solid, a liquid and a gas. This one's a gas. This one's a liquid. And this one is a solid. So my answer is B. Overhead power lines are made of aluminium with a steel core as shown. So they've given me a diagram, and so I've got here my steel core in the centre, and then I've got the aluminium around the outside, and they've given me some properties of steel and aluminium. So here's my properties. I've got the density in grams per centimetres cubed. The little -3 means is the same as writing grams per centimetres cubed. And so I have 7.87 grams per centimetres cubed of steel and 2.70 grams per centimetres cubed of aluminium. Then I've got the strength. Steel is high, aluminium is low. So the question says explain. So I know I'm going to have to use my point explanation. Explain why the power lines are made of aluminium with a steel core rather than pure aluminium. So why am I wanting the power lines made of aluminium with a steel core rather than just pure aluminium? So I'm looking at my table here and looking at the difference in properties. Well, I know that aluminium is not very strong, and so that wouldn't be good at all for power lines. So my point is that steel has a higher relative strength. I could just write strength, but I'm going to use exactly the information they've given me in the table. So steel has a higher relative strength. That's my point. So I need to make my explanation. So that's good because it makes the power line stronger. Okay, so that's my 2 marks there. Okay, now I can go on to part C. And part C, it says the pylons are made of steel. The steel is mainly iron. Iron is extracted from iron oxide Fe2O3. In the production of the iron, carbon dioxide is also produced. Calculate the relative formula mass of carbon dioxide, CO2. So they've given me the relative atomic masses. Carbon has a mass of 12, oxygen has a mass of 16. If they didn't give this to me, remember that I do have a periodic table at the back of my exam paper, so I could look it up on there. So they want me to work out the formula mass of carbon dioxide. So if I look at the formula they've given me, CO2 has got 1 carbon and 2 oxygens. So to work out the formula mass, I add 12, which is the mass of carbon, to oxygen, which is 16 times 2 of them. So that gives me 12 plus 32, which gives me a mass of 44. So the formula mass of carbon dioxide is 44. The equation for the reaction used in the extraction of iron is 2 iron oxide, 2 Fe2O3 plus 3 carbons are used to make 4 irons plus 3 CO2. calculate the maximum mass of iron that could be obtained from 640 tonnes of iron oxide Fe2O3. And again, they've given me the masses of the atomic masses of iron, which is 56, and they've also given me the formula mass, so I don't have to work it out, of iron oxide Fe2O3, so it has a mass of 160. So if I look, I'm going to write my equation out again so that I can see exactly what's going on. So I have 2 Fe2O3 plus 3 carbons makes 4 irons plus 3 CO2s. And what I'm interested in is the maximum mass of iron, so this one here, that can be made using 640 tonnes of iron oxide. So I'm not interested really in the carbon or in the carbon dioxide. So they're telling me that I'm starting with 640 tonnes, okay, but I'm going to start by looking at the masses, okay. So I'm going to write here atomic mass. So the atomic mass of iron oxide, they're telling me, is 160, and the atomic mass of iron is 56. But I know that in my equation I've got 2 iron oxides, so I've got 2 of those, and 4 irons, so 456. So if I calculate that, that gives me 320 iron oxide to make 4 times 56, which is 224. Remember, you can use your calculator to do this. So that tells me the atomic mass, so that I've got 320 amounts of iron oxide will give me 224 amounts of iron. Now if I go back to the equation, the question, they've made this nice and easy because they've said, okay, we're starting with 640 tonnes. So now if I look at my number of tonnes, 640 tonnes, okay, how much am I going to make? I know that if I have 320 amounts, or 320 tonnes, I'll make 224 tonnes. So what do I have to do to go from 320 to 640? I've got to double it. So if I have 640 tonnes, if I double my answer for iron, I get 448. So I know that I could make a maximum of 448 tonnes.